Reporting for Fun Robotics Network, I'm Yashis, and with me today on Behind the Bot is Team 10-019 NYAN Robotics, who just recently won the Illinois State Championship and punched a ticket to Worlds. Their robot is really unique, with incredible active intake and incredible outtake slides that perfect their robot. Learn more about their robot on Behind the Bot. So to get started, let's talk about your design plan and process for the beginning of the season when the game challenge was first released.
For sure. So beginning of the season, we actually did robot in 3 days. Although we weren't that successful in building a robot, it was a great idea to just brainstorm. And at the beginning of the year, we all kind of joined together for 3 days and just throw things at a wall and see what sticks. So that's how we initially came up with the idea of vertical slides with an active intake and horizontal slides in the front.
Yeah, so moving on to your drivetrain, what is that composed of, and how are you tracking it during software, during autonomous and stuff like that?
So for drivetrain, we run a parallel plate drive train with four 435 RPM motors, and they are belted to the wheels. We use the N.Y.A.N Build the wheels. And for tracking, we actually use two Go Build odometry pods, the 4-bar pods, along with pinpoint, so that we have more precise tracking. And we additionally have the auto sensor as a backup.
So moving on to the active intake, how did you decide on the idea for an active intake as opposed to a claw intake? And how did you iterate it over the season to make it as fast and effective as it was today?
At the start of the year, we always knew we wanted to make an active intake just because it's a lot more efficient and the more margin of error. So how we first come up with a triple spinner, but that often led us to not breaking the sample to come parallel to the back. We then went with the wrapped version with a single spinner that automatically aligns it. This was good, but it later broke. So then we moved up to aluminum. With this aluminum, we have spinners up front, and the spinners are made of just surgical tubing, but inside there's actually a TPU core. And to keep it in place, we just have a micro here with a color sensor that automatically flips whenever it detects the right color.
Yeah, that's incredible. So moving on, let's talk about your transfer and outtake mechanisms and how that's so efficient during autonomous.
Yeah, so this season we implemented a command scheduler that allows us to run commands sequentially and in parallel. And additionally, we also have a ton of sensors, so we know what the position of each one of our subsystems are at any moment in time. So on our outtake, we actually have an analog wire. We use the Axon Max Plus. We have 2 servos for redundancy, but we only use the positional data on one of them. And on our intake, we also use an analog wire on one of our linkage servos. And this allows us to just know its position, and in coordination with our command scheduler, we could run commands sequentially and in parallel.
Yeah, and then diving a little bit more into the actual outtake claw portion of that, how did you decide on a claw for outtake as opposed to like a bucket or some sort?
So we knew to do the active, we would need something to pick up specimens if we wanted to score them, and the only really option was a claw. So first couple league meets, we had a claw with no mobility except the actual open itself and the rotation. But now we've added a wrist here and a wrist here, which allows it to pivot down and pick up specimens like this. It also helps a lot in transfer because our intake is, we can't just go straight vertical. We actually have to rotate the claw down and then pick it up. So that wrist helps actuate that movement in order to score.
And then let's talk about your slides for both intake and outtake. What are they powered by, string, linkage, and explain a little bit more about it.
So the 2 types of slides that we use are both Misumis. For the linkage, we use for the front slides, we use a linkage powered by servos, and it's actuating 2 SAR 230 slides from Misumi. There is no strings, just a linkage here. And for the outtake, we actually use 2 Misumi SAR 240s, and they are powered by 3 motors running in parallel, and they are strung with just normal string.
And then lastly, let's talk about the hang and why you guys decided to choose for slide hang, which could only do like a level 2 instead of something that might get you a level 3.
Sure. So as soon as we first built our prototype, League Meet 1, we realized we were going to consume most of the servos. And then once we refined it for League Meet 2 and League Meet 3, we actually figured out we were using all 12 servos and 7 motors. So at that point, we decided it would be more beneficial for us to just focus more on cycling samples fast and keeping the whole intake and outtake the same, rather than trying to refine some points of it in order to save some servos that would be required to do like a level 3 hang.
Yeah, that's awesome. And then lastly, let's talk about your any advanced software development tools that you use on your robot to make it as efficient as it is.
Yeah, so to make sure we can iterate our software really quickly, we use FastLoad along with FEC dashboard, and this allows us to really test servo positions and our subsystems and our code logic really quickly. So
Yeah, awesome. Before we go, is there anything you guys would like to say to the audience? Any last notes regarding your robot?
Regarding our robot, not so much, but we'd like to shout out Warbots, team 10415, our partner during the finals matches, and we thought we were a good combo and it worked pretty well.
Awesome. Thank you so much for joining us on this Behind the Bot, and thank you to the viewers on Fun who support